This is a real quick video about collisions in 2D and 3D, so what happens when objects are moving at an angle to each other. We're not going to spend a whole lot on this in this class just because the math gets more complicated than it's worth doing for kind of intro level, and we can just talk about it in broad concepts instead. So 2D and 3D, when objects are moving in multiple dimensions, momentum is conserved in each dimension individually. So in other words, the left-right momentum is conserved. The up-down momentum is conserved. And the forward-back momentum is conserved. Well, I'll sketch a 2D example here. So for example, if I have an object like this, and an object like this, and they're moving two clay balls and they stick together, well, if we calculated the momentum of this guy and said that its momentum is equal to, let's say, 3 kilogram-meters per second to the right, and this one, the momentum is equal to 4 kilogram-meters per second up, well then we know the final momentum will just be the sum of that. 3, 4, so it's going to have 5, if they stick together, 5 kilogram-meters per second momentum, kind of up and to the right. And that's because this guy, we end up with still having our 3 to the right, and we end up with still having our 4 up. And if those combine together, we get that 5. Same thing if it was in 3 dimensions. So we're really just talking about this so that you know the broad concept. If we have any problems on this or you're quizzed on it, it'll just be kind of like, can you eyeball what direction the thing should work? Or if, let's do another example here. Say I have an object that's moving like this initially, and an object that's moving up initially, and then after the collision, I know that I still have an object moving to the right. What should the other object be? Or this one's moving, bounces off and goes up, sorry, it goes down and to the right. Well, we know the other object probably has to go really hard up because it has to keep this momentum and counteract the downward momentum to end up with the total here. That's just a real rough example. The big idea is just kind of what you would normally expect from things bouncing intuitively. We're explaining why that is, and it's because momentum is conserved in all dimensions.